Shri Gurubhyo Namaha. Welcome to our online class. Previous class we have discussed about some of the physical properties of metals and non-metals lesson. Specifically we went through the topic of physical properties of metals and other properties like sonorous and color of metals we will discuss now. And after discussing those topics, we will go in detail about the chemical properties of metals. Last class we have checked about the properties of metals, important properties of metals like malleability, ductility and density of the metals also we have discussed, and how do they conduct electricity and heat. All these things we have discussed in the earlier class, children, and now we are going to going in detail about the density and sonorous capacity of the metals. Now, if you check the next property of metal is high density, they possess high density. Metals have generally high density, which means that they are heavy substances. Normally, whenever you take metals, it will be holding more weight, so that it will be heavy in nature. Example, density of iron, it will be ranges from 7.8 gram per centimeter cube. Okay. If you take density of iron, the density of iron is 7.8 gram per centimeter cube. Whereas sodium and potassium, they are the soft metals, they are not hard metals and they are not heavy too. So that they are the exceptions here, they will possess less density only. And density of sodium, if you take 0.97 gram per centimeter cube. And for potassium, it is 0.86 gram per centimeter cube. So, if you take heavy metals like iron, copper and aluminium, they possess high density. Specifically, iron is the hard metal as well as it is tough too. So, that it possesses the density of ranges 7.8 gram per centimeter cube. Whereas sodium and potassium are soft metals. So, they will be having low density only. So, sodium, density of sodium is 0.97 gram per centimeter cube, whereas for potassium it is 0.86 gram per centimeter cube. Next property of metal, and it is a very important property of metals, it is sonorous capacity. Sonorous means what? It is nothing but whenever metals are beaten, okay, using the other articles, or if the surface of the metals are beaten with some other hard materials, it will be producing a ringing sound. So, sonorous means what? Capable of producing a deep ringing sound, okay, capable of producing deep ringing sound when it is strike. The property of metals of being sonorous is called what? Sonorousness or sonority. It is a property of the metal which produces the ringing sound, is known as what? Sonorousness or sonority. Due to this property, metals are used for making bells. You could have seen in temples and church also, children. So, bells are made up of metals. Okay, and it will be used for making the strings of musical instruments, string instruments like violin, guitar. Okay. So, these are the musical instruments where the strings of these musical instruments are made of what? Metals. Okay. So, that they will be giving the sonorous, that means the ringing sound. So, when the musical string of musical instruments are made with metals, we can get the pleasant sound from that. And the next property is color of the metals. Normally, metals will give silvery grey color, or it will be having yellow color, as I said, gold metal, okay, which gives a dark gold, that means yellow color. Whereas the other metals like iron, silver, aluminium, zinc, okay, they will be giving the grey, silvery or grey color like this. And copper metal, which is reddish brown in color. When you take copper, metal, which will give reddish brown color. okay, reddish brown color, right. So, next we are going in detail about the chemical properties of metals, children. So, how to learn actually physical properties, what are called physical properties? When we look at the metals by the appearance given by the metals as well as the other properties like physical observance. Okay, we could check the physical properties, but chemical properties, if we want to study in detail about the chemical properties, we have to check in detail how these metals react with the other elements. Specifically, how do they react with oxygen, that means in air, okay, and also how do they react with water, how metals react with acids, how do they react with non-metals. Okay, so all that we are going to discuss in detail. So, when you take metals, the chemical properties of metals, we are going to learn these topics under this one. Reaction of metals with oxygen, okay, with oxygen in air, reaction of metals with water. So, with the water, because metals have the tendency, that means some of the metals, if the metals are hard, they will not show any reactivity towards water. If they are less reactive, they will be readily reacting with the water. Okay, highly reactive metals, that means they must be soft metals like sodium and potassium. If you take sodium and potassium, okay, they are considered to be highly reactive metals. Highly reactive metals. Okay. So, whenever they are immersed in water, that is why already I told you that these metals would be stored in kerosene, they will be immersed in kerosene for preservation, because when they are taken out, when they are getting contact with the atmospheric gases or atmospheric air, then what happen? Immediately they catch fire. Okay. So, to prevent that, these metals have to be prevented, that means what? Immersed in kerosene. Okay. So, as they are readily, that means highly reactive, they will be readily reactive with water. Okay. So, here we have to check with the reactivity of the metals. If the metals are highly reactive, then they will be readily reactive with water also. If the metals are less reactive, that means the tendency of the metals in reactivity series is less, then they will show moderate reactivity with water. Okay, and some of the metals will be very hard and they will not be showing any reactivity towards water. So, about that in detail we are going to discuss in this topic. Next, reaction of metals with acids. Okay, reaction of metals with acids. You know children, acids are source substances and they release hydrogen ions. Okay. So, here when metals react with acids, they liberate hydrogen gas from the acid, right. And reaction of metals with metallic salt solution depends on the reactivity series of the metals. When these metals are treated with the same metallic salt solution or the other metallic salt solution, how do they react? All that we are going to discuss in detail in this topic. And next, reaction of metals with the non-metals. Actually, metals have the tendency to donate electrons, whereas non-metals have the tendency to accept electrons. Okay. So, metals will donate electrons, whereas non-metals accept those electrons, so that the donated electrons by the metals will be accepted by the non-metals, thereby ionic compounds are formed. Okay, and the ionic compounds are formed due to the emergence of ions, different type of ions produced by metals and non-metals. Normally, metals donate the electrons so that they produces cations, that means positive ions, will be produced by metals. Whereas non-metals accepting the electrons, thereby they produces negative ions. Non-metals produce negative ions. So, the positive ions are called as what? Cations. Positively charged ions are called as what? Cations, and negatively charged ions are called as anions. So, we have a separate topic of formation of ionic compound, children. We will discuss in detail when we go to that topic. Now, the first chemical property of metals, reaction of metals with oxygen. You know that the formula of oxygen is molecular oxygen is O2. Okay, so where metals will acquire this oxygen? It is from atmosphere or from heat energy. Okay, so normally metals reacts with oxygen and produces metal oxides. Oxides of metals will be produced. Depends on the valency of these metals, they will be producing monoxides, dioxides and trioxides. If the metal is monovalent, okay, then monoxides will be produced. If the metal is divalent, dioxides are produced. Like that, it depends on the valency of metals. When they combine with oxygen, they produces oxides, and mostly metals produces basic oxides. Metals produces what type of oxides? Metal oxides are normally basic in nature. I will tell you later how they are considered to be basic oxides. Okay, children. And there are some exceptions, because some of the metals will be producing amphoteric oxides. Okay, when we learn about the nature of oxides, I will tell you in detail about the type of oxides produced by metals, children. Okay. So, here we have two examples. That means when copper is a metal with reddish brown color. Okay. So, when it is heated, from the heat energy, it combines with the oxygen and produces the oxide of copper, and the formula of copper oxide is CuO, right? And this oxide, that normally the metal will be reddish brown in color. When it is combining with oxygen, it produces the oxide which is black in color. Whereas aluminium is another metal which combines with the oxygen to produce aluminium oxide. Okay, and this oxide is somewhat different from the other oxides, because aluminium is the lightest metal and also comparatively it is less reactive only. So, it produces amphoteric oxide. Amphoteric oxide. Definitely I will explain you, children, what is meant by amphoteric oxide. So, let us see the other examples how metals produces oxides when they react with oxygen. So, let us take magnesium, the metal with the symbol Mg. Okay. When magnesium is reacting with oxygen, that means when it is burnt, right. So, when magnesium ribbon is burnt, directly it is getting contact with the oxygen which is supplied by the heat energy. Okay. So, when it combines with the oxygen, it produces the oxide, that is magnesium oxide. Okay. So, here we have to balance the reaction, balance this equation. So, to balance it, write 2 in front of magnesium, because when we write MgO, this is the correct formula of magnesium oxide, but oxygen is not balanced. To balance this oxygen, we have to write 2 in front of magnesium. So, that here we will be getting 2 MgO. Now, the equation is balanced. Okay. So, which means that 2 molecules of, that means 2 atoms of magnesium is required for 1 molecule of oxygen to get combust, and then it produces 2 molecules of magnesium oxide. Same way, the metal zinc reacts with oxygen, produces zinc oxide, and magnesium, zinc are divalent elements. Okay, divalent metals. Okay, so that magnesium produces Mg2 plus ion and zinc also produces Zn2 plus ion. That is why when it combines with the oxygen, they produces the oxide which are basic in nature, and the formula should be written as ZnOMgO. Now here also we have to balance the equation the same way like magnesium. So write 2 in front of zinc, so that now you will be getting 2ZnO. Okay, now the equation is totally balanced. So these metals we can react with the oxygen to produce their metal oxides. The same way, when we take sodium, the formula of sodium is Na. When it reacts with oxygen, readily it will react with oxygen and then produces sodium oxide. If you take sodium, the valency of sodium is 1 plus and oxygen it is 2 minus, and you know very well that how to write the molecular formula of sodium oxide. By crisscrossing the values, that means the valency of the metal and non-metal will be getting Na2O. This is the actual formula. Okay. So, Na2O, sodium oxide. Now, to get the sodium oxide, when we have to balance this equation, here we have 2 oxygen, that means molecular oxygen, 1 mole of oxygen which contains 2 atomic oxygen. But here we have Na2 in the product side. So, what we have to do to balance this equation, write 4 in front, because when we write 2, even the reaction will not be balanced. Okay. So, that now we have to adjust the product side, that is 2Na2O. Okay. So, this is how metals react with oxygen to produce metal oxides which are basic in nature. Okay children, so how do we call these metals oxides are basic in nature? Let us go in detail and prove that how these metal oxides are considered to be basic oxides in next class. Thank you.